This is example number 7 of the AEC structural exam or practice exam, and you want to find what x is. This is a fulcrum, so it's pretty much a teeter-totter, and you want to find out where you need to pin or where do you need to support the teeter-totter so it's balanced. In essence, it is a sum of the moments problem. You have to find, you want the moments to be equal about what point. So you have to make this force times distance equal to that force times distance. 50 pounds times what distance is going to equal 250 pounds times the distance. So let us begin. Like most problems, we are going to start with the sum of the moments about point, we'll call this point. I guess we could sum it about this point, or this point. Kind of depends which one you want to, but let's do it about this point. A point where we are from x, from this support. Let's call that A right there. Point A. So the sum of moments about point A equals 0. And let's say that this direction is positive. So at first we say, okay, well, how far away is 250 going to be? Well, it's x, we know that, and it's going to be in negative. So let's say negative 250 pounds times x distance. And then we also have 50 pounds at, well, what is it? Shoot, we don't really know, but we do know that this is 20 from this support to this support. Or not support, but that's the load to this load. The end of the beam to end of the beam is 20 feet. So if we know the total distance and we know that distance, it's this 20 minus x is your distance. It's going to be in the positive direction. So we're going to say plus 50 pounds times 20 foot minus x feet. And that's your equation right there. So let's go ahead and simplify this a little bit to make it easier to look at. 0 equals negative 250 pounds x plus, well, shoot, I messed up. 50 times 20 is 1,000 foot-pounds. And then 50 times x is negative 50 pounds x. And you can, it might be simpler if you go ahead and just say, oh, I'm going to ignore these units right now. It kind of gets confusing if you do that, if you're not used to it. So you could do that, and you could rewrite the equation negative 250 x plus 1,000 minus 50x. And just remember that the units are in there, and your final x is going to be equal to foot. And as long as you don't change any units, like anything pounds to kips or feet to inches, you should be fine. So let's keep on going and simplify this a little bit further. You have negative 250 minus 50 would be negative 300x plus 1,000 equals 0. Then let's go ahead and get rid of, I usually try to go to positive on both sides if you can. This is negative, you can take that to the positive side, or to the 0 side, it'll make it positive. So let's add 300x to each side, 300x over here, and you have, these obviously will cancel out. 300x minus 300x equals 0. Then take 300x equals 1,000. And that will equal, x equals, obviously you do this, 300. 1,000 divided by 300 is 3.33 foot. And that is x. So you go in here, this will be 3.33 foot. This distance will be 20 minus 3.33 foot, which is what? 16.67 foot. And that is your answer. And I know I said at the beginning that you can sum it about this point or this point. But really don't want to do that, and that's not going to help because you have an unknown distance. You want to, and you have an unknown reaction right here. You want to go ahead and you only want to have one unknown. So if you know, hey, if I sum the moment about here, this reaction is going to be going through that point, and therefore the moment's going to be 0. So take back what I said earlier about you could sum the moments about here or there. If you're going to end up having the distance as unknown and the reaction, which is just going to make it worthless. So you want to sum it about point A for sure.